Good morning, guys. How are you? Welcome back to the channel. I hope you're all doing good. Today, we're going to dive into how to sort a linked list using values or swap by swapping values instead of swapping pointers. In linked list or any other data structure, we have two options to swap or the data structure. It's either by swapping the values from inside the data structure bases, like let's say in linked list, the bases are the nodes. So we have two options. One option, which is easy but less effective when dealing with large programs, is to swap the data from each node into the another, but while keeping the nodes addresses the same. Like, we're not just swapping the nodes order. And the other option, which is harder and more complex and advanced, we can just swap the entire node along with its order in the linked list. Like, let's say we have had, third, second, third, final. We can just swap the values and any other we want from head and put it into third, and third into second, and second into final, etc. Or we can just swap the whole head and put it in the end, and then the end becomes the head, etc. You got the idea. So I'm going to explain this really quick, real fast. We of course start by including our standard headers that we're going to use, the input, output, and the memory allocation header. I call it that way. I don't know if we call it, but it's just standard library in H. Okay, and we have of course to define our linked list structure. I call node, and it has integer types of data and a pointer to the next node. I decided this time to not just write everything in main, but to split the program into as many functions as I need. So it turns out I need only two functions, but whatever, it doesn't matter. We're going to start by explaining how we wrote this create list. So my idea here is to create list based on user input. So we're not going here to put a condition. So stop the list, or -1 marks the end of the list, no, or whatever value marks the end of the list. I'm just going to ask the user to identify or to explicitly say how much or how many nodes do they want to have inside this linked list before we start. So I of course defined a starting point, let's call pointer, a starting pointer, and a pointer called current. This will go overlap all the other uh, nodes, so we can just traverse the list. I entered a for loop using these simple conditions. The reminder that the integer n is defined here, it will be the parameter that the create list function will take. Then inside the for loop, each time we iterate, I'm going to create a new node that is going to be the actual node in the linked list. And I also allocated memory for this node, so it contains exactly as needed memory space, not any more, not any less. And I also assigned the next position for the new node is null. This will help ending a while loop later while printing. So I answered this if statement, if else statement. It is as easy as it seems. Just if head equal null, if head is null, head is a new node and current is a new node. We use this just to traverse from here to here. Now current next equal new node and current equal new node, and just printing the data into, I'm asking the user to print or to enter the data into those nodes. And I'm scanning also into the new node, into the data of each new node. Then here I reset the counter of current to head, because in here current next equal null here, because it ended, and it ended here, like no other iteration were made. So in the one before iteration, we did create this node, and we assigned the next value of a new node to be null. So in the last node here, when we stored data, we did stop. We didn't go back there because the n is has because the program has repeated that n times, and the current is still here. Current next equal null. It's as the same as saying new node next equal null. So I did reset current to head, so we can start from the beginning of the list. And I did print while current is not null, just print the data. And this is equivalent, if you're familiar, this is equivalent to I plus plus equivalent. All right. And of course, this is a very important step here to return head, because this is a function of type struct node, and it has to return something, because if it didn't return something, head becomes here a local variable, which I won't be able to use later in the main function. So it has to return something, and this is why we have to create this function as a pointer, because if it didn't, this create list won't point here, thus it won't be able to link the head to the original struct here. So by including this little star, I am assuring that this list or this function creates list based on this definition of my previous definition. Also, the head is also from the same very structure. This is the create list. It is as easy as it seems. Nothing more needed than practice. If you're still new, all you have to do is practice in here. Later, we go to our second function in this program, which is sort, where we actually do it. What is the goal of this program? We have to sort the linked list. So in order to sort the linked list in main, when calling the function, we have to say what do you want to sort. So to explain that to the compiler, we have to include something called, or we want to create a function that takes a whole linked list, which is our structure here, as a parameter. Because I'm going to tell the compiler later in main, sort this linked list. So this is why we have to include this in here, okay? Because this function later will needs to take a parameter, because if I just call sort, it won't assume by itself that there is only one linked list that it was created before, and I have to find it, look for it, and then sort it and then print it. No, it doesn't go that way, and you all guys sure know that. Of course, I did define two nodes or two linked lists. One is called current and one is called index, and I both initialized to null. And of course, a integer called temp, because we're swapping values, not swapping nodes. And I entered this. It's my first time actually doing this for loop. I always go to like for integer I equals 0, I less than something, I plus plus. But this time was totally different because I'm working with linked list. So I did learn something in my head that for takes three parameters. One, the initial condition or the initial start point. Second, the conditions for the loop to keeps going, and the third, how do we increment the starting point, like where we going from here. Okay, we did start here and we continue along as long as this condition is true, but for how long? Okay, so or in which direction do I need to go? Forward, backward, upward, downward? Where do I want to go? If I have this starting point along this condition, where do I use it? So this is the third parameter, the for loop state. And of course, in every sort algorithm, we have to use nested loops. And this is called bubble sort, where you just compare the two consecutive data types to each other. And based on that, you do the sorting. This if index data, if the data at the index is bigger than the data at current, and just swap them. Let's say why. Why? Because current data, I'm starting to assume that the current data is uh, the biggest element already in the list, because I'm assigning into the very first element of the list, and it's continuing forward. If I said that the index, which is at the current, the very next element, let's say I have linked list of 6 node, and another link uh, I have, let's say how. Okay, this is getting stuck. I have a linked list made of, let's say, 7 nodes. Okay, I'm starting to define one pointer called current, and it's pointing to the head. It is the very first element in the linked list. Then I define another pointer called index, and it's pointing directly to the element next to the first element, so next to current. In the very first iteration, it is next to head. So if I'm saying, like, yeah, this is basically just comparing two consecutive elements. Like, I am at index numbers 5, then is at current number 6. If I'm at 7, index is at 8, and whatever. So this condition stays true. If I'm saying if the first uh, the second is a bigger than the first, then just swap them, and it's start in like integer called temp, then swap them, then put temp back into the uh, the first pointer. Then of course I did reset just like I did before, because we have to do that. Why do we have to do that? Because current is here at null. Okay, here it stopped here. Current next equal null. It stopped at the very last time where current was not null. Okay, and I did the print, and of course I returned head because I would have to use it in here. Integer main print f, how many nodes do you want to have, integer value, blah blah blah. I did ask the user for how many integers they want to have, and I said create a linked list starting from head, and it has value node. Okay, it has nodes, count nodes equal value, and value is a basically user input value. Then I asked it to sort head. If I didn't return head here, it wouldn't know what would have to sort. This return zero is optional for many compilers. Let's test the program to see if it works. As you can see, guys, I already tested, and I assume that it works perfectly. So let's say we have 5 nodes, 0, 8, 7, 7, 6, minus 9. And the original list is 08776 minus 9, as clearly as my input. Wait. So yeah, my input is just like that, 08776 minus 9, and the sorted list is 77860 minus 9. Exactly, it works as intended. Now, if you're still wondering how this logic happened, I will create a uh, I will create something for you to how, like a diagram, just how I thought about it. I'm just going to take a screenshot of this and place it into this Microsoft whiteboard, and then explain it to you how we did the swap. Where do we insert a template? No, here. No, let's just take a screenshot from here. Okay, we're going to explain this very part. We have to copy it and paste it here. Okay, let's go through this. Of course, you're wondering about this logic in here. Okay, let's go to explain it. Now I say if index, wait. Okay, now I have my laptop in my tablet mode. Now let's say, let's just make this a little bigger. Perfect. Okay. Now we're saying if index, uh, wait, this need to be reset. If index data is bigger than current data, what does this mean? Let's say we have this linked list here and it's all linked that way. This is our current, this is our index. If we're saying that if the index in here is bigger than here, then store the data into from index into the variable called temp. Okay, so now the value of the value here, the value that were here, are now just stored in temp in here. Okay, now to swap, we just have to place the value of here in here. So we have to say index data equal current data. Okay, now we have the value of whatever was here in a integer called temp, which is why we call temp. Then we just assign the value in here to whatever was in here. So current data equal temp, and that is how we sort. Thank you so much, guys, for watching. I hope this video made some points clear to you, and if you have done any kind of these exercises in a different approach, just let me know your approach in the comment down below. And I'm so thankful for you guys. Hope to see you very soon again. Thanks for watching and stay tuned for more.